Right, Unit 2, calculator paper. Question 1, solving equations. So I'm going to collect the x's on the left. So I'm going to bring minus 4x over here, so I end up with 10x is equal to 30, because I'm going to take plus 13 over there at the same time, so x equals 3. I'm going to take 5 over, so I get 2x equals 5 times 40. So 2x equals 200, so x will be 100. This question I'm going to take 2 over and divide first, so I end up with 30 minus x equals 22. So then I take the x over there and the 22 this way, so I get 30 minus 22 equals x, so 8 equals x. Question 2, estimated mean. So I need to add 2 extra columns. I need a midpoint column and I need a midpoint times frequency column. So my midpoints are going to be 5, 6, 7, 8 and 9. 5 4s are 20, 6 2s are 12, 7 nothings are nothing, 2 18s are 16 and 2 9s are 18. Add these up, I get 66, divided by, there are 10 altogether, so my estimate is 6.6. The modal class is the class of the most in, so the class of the most in is 4.5 to 5.5. The median is where the middle person is, and that would be the 5th day. So we've got 4 here, the 5th day would be in here, 5.5 to 6.5. Part B, draw a frequency polygon. To draw a frequency polygon, we plot the frequencies against the midpoint. So across the bottom, we plot the midpoints. The first midpoint was 5 against the point 4. 6 against the point 2, 7 against nothing, 8 against 2, and 9 against 2. And for a frequency polygon, we join this up using straight lines going from one point to the next, right the way across until we get to the end of the graph. Question 3. So the first thing we know is the 75 across here, and there's an area in here of 3,900. So if I want to find AE, so AE equals 3,900 divided by 75, as length times width gives us the area, and that comes out as 52 centimetres. That tells me I've also got 52 centimetres by here. The question tells me we've got 25 centimetres here. The area of triangle BDC, so the area part will be 52 times 25 divided by 2, because the formula for triangle is base times height divided by 2. So 52 times 25 divided by 2, 650 centimetres squared. And then BC, so we've got a right angle triangle with 52 and 25. So I'm going to use Pythagoras Theorem, where BC is equal to 52 squared minus 25 squared, all square rooted. So 52 squared minus 25 squared, square root the answer, and we find that it's 45.6 centimetres in length. Question 4. Explain why the label might not be correct. So they have checked how many have exactly 8 in at each point out of 10. So only once do all 10 have exactly 8 in. Now, contains at least 8 peaches. We can't say that that's definite, because on all of these occasions there are boxes that don't contain exactly 8. We don't know whether they contain more or less than 8, but we can say that because we don't know that here there are the 2 boxes left here that might contain more or less, that's why the label is not suitable. So, relative frequency. So they've checked 10 boxes here, 20, 30, so after 4 AM they'll have checked 40 and 50. Now to find the relative frequency, we do this, the actual number of boxes successful divided by how many were all together. So 8 divided by 10, which is 0.8. 18 divided by 20, 0.9. 25 divided by 30, 0.83. 32 divided by 40, 32 divided by 40 is 0.8, and 41 divided by 50 is 0.82. Now to plot this, you just need to set up a sensible scale across the side. So we're going from 0.8 up to 0.9, so we could go 0.82, 0.84, 8.6, 88, 90. So I'm going to use 0.82, so 0.8 would be at the bottom, 0.84, 0.86, 0.88 and 0.90. So at 1 AM it was 0.8, At 2 AM it was 0.9. At 3 AM it was 0.83. At 4 AM it was 0.8 again, and at 5 AM it was 0.82. The box is selected at random. What's the best estimate of the probability that it contains exactly 8 peaches? So to get the best estimate for the probability, we look at the end column. So if we want the most accurate estimate, we need to look at the biggest amount of data. So the biggest amount of data was at 5 AM, where they'd now checked in total 50 boxes and found there were 41 with exactly 8. So our best guess is 0.82 of the probability. Similarity, this is the larger shape and this is the smaller shape, so the scale factor is taking the relevant linked sides and dividing them, so we find the scale factor is 1.25. If I want to find the larger shape, I take the same value in the smaller shape and I times it by the scale factor. And if I want to go the other way, so if I want to find a smaller side, I take the larger value and I divide it by the scale factor, and I find that x is 2.8 and y 3.8. Rearrange the formula. So I need to get k on its own. So the first thing I'm going to do is take the 3 over and divide. Then I'm going to square root both sides to get k on its own. Make sure you draw the square root sign all the way around m over 3, otherwise you will lose marks. When there's the same letter in more than one place, factorise it first. So I take e out, g out as a common factor, and then leave the g where it is and divide by the e plus f. 13 million in standard form. 13 million is the number 13 with 1, 2, 3, 4, 5, 6 zeros on the end. So it's going to be 1.3 times 10, and then I've moved 1, 2, 3, 4, 5, 6, 7 places, so it's to the power of 7. So 0.8 here, and it also tells us that the probability of soup and an apple is 0.32. So the probability when I do this one times this one is 0.32. So I must have 0.4 in the gap. So there's going to be 0.2 here, 0.6 here. It tells us that these two things are independent, so we're going to have 0.6 and 0.4 again down here. Does not by soup and does not by apple. So no soup, no apple. We get 0.2 times 0.4, which is 0.08. Circle theorems. So we know that each of these here must be 37 because it splits it in half. We also know we must have a right angle here and here. Now in this triangle here we have 37 and a right angle, so if I add the 90 and the 37 together I get 127. The three angles in a triangle add up to 180, so I get 180 minus 127, which equals 53 degrees, so I know there's a 53 here. As this setup is identical on both sides, we also know there's a 53 here. We now know that these are both radii of the circle, so I can do 180 minus 53, which gives me 127, and if I half that to get 63.5, I have a 63.5 here, 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 and here, so they are all 63.5, and one of the ones I want is OBC, so from O to B to C, we've just established that's a 63.5. From A to C to B, so from A to C to B, we know there's 63.5 either side, so that's a 63.5 plus another 63.5, so that's a whole total of 127. The radius of the circle is 8. Calculate the perimeter of the quadrilateral TAOB. So the shape TAOB is something along these lines, where we have a right angle here and a right angle here. So we have two right angle triangles. We know 8 and we know 8. We also know 37 in both of these. So we need to find the lengths here, which we can do using trigonometry. So we have the opposite, and we're trying to find the adjacent. So we can say that tan 37 equals 8 divided by the adjacent. Swap these around and we find that the adjacent is equal to 8 divided by tan 37, which if you do that on your calculator you get that that is 10.6. Now we know that these two lines are the same, so we have 8 plus another 8 plus a 10.6 plus a 10.6, so in total we have an area of 37.2 centimeters square, or perimeter of 37.2 centimeters.